Today we're going to be learning about chance within different circumstances of uncertainty that may be encountered. Understanding the probability of surprise situations and their outcome will better help you understand a world filled with uncertainty. So what is chance? Life is filled with uncertainty, and many times we suspect the wrong outcome of a situation due to quick assumption. However, many events in life arise simply from chance. Understanding the probability of these surprise situations and their outcomes are better going to help you understand this world filled with uncertainty. Chance originated in 1654 by two French mathematicians, Pierre de Fermat and Blaise Pascal. Javert de Mer was the philosopher behind their brilliance, and studying his way of gambling brought a new comprehension to the stakes at risk. Fermat and Pascal worked to further advance his concept within the world of mathematics, which ultimately they did. This is what we're going to be studying today. This section is going to focus on fully comprehending the surprises of life so ultimately they become expected. We determine these outcomes by studying past situations, comparing, and analyzing what could be to come. To better understand this, we're going to take a look at some scenarios that will help us develop a method for determining the outcomes of these situations. The first scenario we're going to take a look at is for a game show. So, one of three doors has a great prize hidden behind it. The other two are nothing but a disappointment. The host of this game show knows where the prize is hidden. After the contestant chooses their door, the host opens another door with no prize behind. The contestant is then given the choice to stick with the door they previously chose or switch to the remaining door. So the question here is, would you take the chances of switching doors or staying? You're probably expecting to have a 50% chance of choosing the right door, meaning it wouldn't matter if you switched or stayed. However, it may come as a surprise that switching doors will actually give you a higher chance of choosing the correct door. If you switch doors, you would have a 2 in 3 chance of winning due to the losing door already having been revealed. And this picture kind of gives you a visual representation of that. So this link is a way to try it for yourself. It'll give you 3 doors to choose, and it'll help you switch or stay. And after playing, statistics are actually shown at the bottom of the game, and it's been proven that switching doors has actually had a higher probability of winning. So the next situation we're going to take a look at is about children. We're going to look at 2 different cases. So the first case, for say, a person says they have 2 children. Then you proceed to ask if the older one is a boy, and they respond with yes. The second case, the person states they have 2 children, and you proceed to ask if at least one of them is a boy, and they respond with yes. So the question is, what is the probability of the person having 2 boys? So, quick assumption may lead you to expect there's a 50-50 chance within each case. This is true for the first case. Knowing one of the children is a boy, the only remaining probability is a boy or a girl. However, the surprise within the second case is that there's actually a 1 in 3 chance. The probability could be as followed: boy then girl, girl then boy, or boy then boy. It's for this reason we must understand the importance of recognizing chance rather than jumping to these simple conclusions. So there's a lesson that lies here. You may be wondering, why is this of importance? Determining the likelihood of these uncertain events will help the surprises of life actually become expected. This reflection may help you to lead and think in a different light. Expected results can often lead to a surprise of new perspective. We're now going to take a look at some questions to consider. These problems will help us further understand the concept of chance. For the first problem, let's say the newest version of the game show we previously discussed now has 5 doors instead of 3. 2 doors have cars behind them, and the other 3 doors have nothing. What percentage of the doors have cars behind them? Take a minute to think about it. The answer is 40% of the doors have cars behind them. And this is because 2 of the 5 doors have a car, and 2/5 is equal to 40%. These are the results we expect because it's the probability. However, again, chance may bring surprise, and the results could always be different. For the next problem, you're going to need a deck of cards. So you're going to remove 3 cards from a deck of regular playing cards, a king and 2 aces. You're then going to shuffle these 3 cards and choose one at random and record whether it's a king or an ace. Repeat this experiment 20 times. And the question is, what percentage of the time did you select the king? I selected a king 35% of the time. The results are going to be different for each experiment. We expect the results to be 33%, as this is the probability. However, again, like the last situation, chance has an effect on these results and leaves us with surprise. You never know what you're going to get.